Welcome. In this video, we will discuss how to find the length of an arc using integration. The concept of arc length is given a certain graph or curve. We would like to find how long that curve is. If we imagine taking some curve and just stretching it out, how long is that length? We have a formula using integrals, and the formula we can set up to be integrating in terms of x or in terms of y. We have these two expressions that we could use. The formula is to integrate dl, where we can choose either one of these expressions for dl. Let's talk really quickly about where this formula comes from. We're not going to work through a very rigorous proof, but we'll have a hand-wavy heuristic argument for where this formula comes from. Imagine that we have some curve between these 2 points, and let's think about zooming in on one small portion of the curve. It's been magnified here, and imagine taking just one short length of curve. We'll call that dl. That's just representing a small change in length along that curve. If we create a triangle, we can get a horizontal leg of dx, a small change in x, and a vertical length of dy, a small change in y. We can find dl by using Pythagorean's theorem. dl is the square root of dx squared plus dy squared. This is simply from Pythagorean's theorem. Now, take this expression, divide everything by dx. This might seem a little bit strange, but we're going somewhere with this. Divide by dx, and I can bring that into the square root if I take the dx and square it. So inside the square root, the dx turns into dx squared. So we have dx squared plus dy squared over dx squared. This fraction can be split into two fractions. We'd have dx squared over dx squared plus dy squared over dx squared. Now, dx squared over dx squared is simply 1. So we have 1 plus dy over dx squared. If we solve this for dl, we have, if we think about eliminating the middle steps here, dl over dx equals this square root. So multiply both sides by dx to solve for dl. We have dl equals the square root of 1 plus dy over dx squared times dx. Now, this is hand-wavy. We didn't really work through this rigorously, but this at least should give us an intuitive idea of where this formula comes from. dl is the length of one small portion of the curve, and to find the total length of the curve, which we can call L, we add up all of those small lengths dl. To add up a bunch of tiny pieces, we take an integral. So we integrate dl. That's where we get this expression for dl. Similarly, we could get a very similar expression in terms of dy. Let's practice using this formula for a specific example. Let's set up an integral to describe the length of the arc of the curve y equals x squared between these 2 points. The length that we're looking for is this length here. We want to find how long is that small portion of the curve. Well, the formula is the integral of dl. And dl we have 2 choices for. Let's first use dl equals the square root of 1 plus dy over dx squared. That's the derivative of x squared. So on the one hand, we have the integral of the square root of 1 plus, and then the derivative here, dy over dx, is 2x. So 1 plus 2x quantity squared dx. And since we're integrating with respect to x, we use the x values of these points. So we integrate from 2 to 3. Let's set this integral up if we were integrating with respect to y. If we integrate with respect to y, we're going to use the expression for dl. dl equals the square root of 1 plus dx over dy squared, dy. In this case, we need to solve our given equation for x so that we can take the derivative of x with respect to y. So y equals x squared. If we solve for x, we get x equals plus and minus the square root of y. We're only concerned with positive values for x, so we're only concerned with positive the square root of y. That means that dx over dy, we're switching the way that we normally think of these letters, but the derivative of x with respect to y is the derivative of the square root of y. That's 1/2 y to the negative 1/2. That's dx over dy. Use that in this expression for dl, and a second integral that describes this arc length is the square root of 1 plus dx over dy squared, 1/2 y to the negative 1/2 squared dy. This integral uses y values for the limits. We're integrating from y equals 4 to y equals 9. Both of these two integrals are equivalent to the same value, and they describe the length of this arc of the curve.